Now, let's understand the basic rules for IUPAC nomenclature of branch chain saturated hydrocarbons, generally specifically alkanes. Now, the first rule is we have to select the longest chain. So, we have to select the longest continuous chain of carbon atoms in any molecule. So a chain that basically contains the maximum number of carbon atoms. So that is regarded as the parent or the root chain. The second rule is the position of the substituent. Now this is again a very important rule. Here the number of carbon atoms of parent chain, let us say it is 1, 2, 3 or something like that. They start from the end, which gives the lower number to the carbon atoms that carry the substituents. Now the third rule is basically the rule of lowest set of locants. Now in this rule, we basically select the end of the parent chain, which gives the lowest set of locants. We prefer it for the numbering. Now the fourth rule is the presence of more than one same substituent. So this is again a very important rule. Now if the same substituent that is present more than one time, so we follow this rule. Now moving on to the next rule, that is our fifth rule. That is naming different substituents. Now if two or more different substituents, if they are present, then how we name the different substituent? In this rule we will be studying the detail with examples. Now moving on to the next rule, that is the sixth rule, naming different substituents at equivalent positions. Now suppose we are having any two different substituent, but they are present at the equivalent position. So how can we name those substituents? We will learn about those examples in this specific rule. So our next rule is naming the complex substituents. This is again a very important rule, that is the naming of complex substituents, or we can say substituted substituents. So these are basic rules for IUPAC nomenclature of branch chain saturated hydrocarbons, or simply alkanes. So we have to select the longest chain, then the position, then lowest set of locants, etc. Now let's discuss these rules one by one. The first one is the longest chain rule. I have provided an example. Let us suppose any student chooses the marked longest continuous chain of 9 carbon atoms, but suppose there is another class of students who does not choose this type of continuous longest chain. Instead they chooses this as a longest continuous chain. Now the problem with this chain is that if we mark the number of the carbon atoms, the number comes out to be equal to 8. So the first chain comes out to be 9 carbon atom, but the second one is of 8 carbon atoms. So according to this rule, we have to select the longest continuous chain, that is the chain which has maximum number of carbon atoms. Now there is important note regarding this, that if two different chains of equal length, suppose we have two different chains and their lengths are equal, then how will we decide which one is selected? So we say that the chain with the maximum number of side chains or alkyl groups, that is basically selector. So this point is again very important, that if the two different chains, they are having equal length, then the chain with the maximum alkyl groups or side chains, that is preferred. Now we will try to understand this note or understand this important point by taking this example. Now suppose we are having this molecule and we have to select the longest continuous chain. Suppose I select this as a longest continuous chain having 7 carbon atoms, but this chain has 3 substituents. This one is the first one, this is the second, and this is the third one. So we have 3 substituents. Now suppose if another student chooses different chain as the longest carbon chain. Now let's plot this molecule again. Now suppose I choose this as the longest carbon chain. So here basically we have 4 substituents. This one, the second is this one, the third is this, and the fourth is this. So we will prefer this as the right answer because this has 4 substituents while the first one has 3 substituents. So now let's discuss with examples the second rule, that is the position of substituents. So if we have different substituents, then how we write the name of the compound. Now suppose we are having this molecule and the substituent attached, that is at the second carbon. Now student decides to number it in the reverse order. Now in the first case the substituent gets the second number, while in the second case the substituent gets the fourth number. So the rule is that we have to give it the least number. So the first one is the correct answer while the second one is the wrong way. Now let's discuss the third rule, that is the lowest set of locants rule. This rule basically says that whenever we have 2 or more substituents, then the end of the parent chain, which gives the lowest set of locants, that is preferred for the numbering. Now suppose we are having this molecule and we are selecting this as the longest continuous chain. So let's give the numbers. So we can clearly see that the substituents, they carry the positions at second carbon, as well as two substituents are present at the fourth carbon. So the set of locants will be 2, 4, 4. Now let's try to understand that if another students want to number the chain differently than the first molecule. We have plotted the same molecule, but this time we will start the numbering from this. So in this molecule, we can clearly see that the substituents, they are getting the carbon number 3 and 5. So the set of locants will be 3, 3, 5. So the rule is that we will prefer the numbering for the lowest set of locants. So this is the correct way, while this is the wrong way. Now it's important to understand a very important topic under the lowest set of locants. We have a rule that is the lowest set of locants versus the lowest sum of locants. Some of us get confused with the lowest sum of locants. Now let's understand the difference between these two rules. Actually, according to the latest IUPAC system of nomenclature, the lowest set of locants is preferred even if it violates the lowest sum rule. So the main preference is given to the lowest set of locants rule. Now suppose we are selecting this as the maximum number of carbons, longest carbon chain. So the set of locants becomes 2, 7, 8. So this is the second, the seventh and the eighth one. Now if we see the sum of the locants, so it becomes 2 plus 7 plus 8, that is 17 in total. Now what will happen if another student wants to give the number differently from the first example? So let's first draw this molecule again. But this time we will number it like this, which is basically different from the first case. So here we can see that the set of locants becomes 3, 4 and 9. And if we do the sum of locants, it becomes 3 plus 4 plus 9, that is 16. So the sum of locants in the second case is lesser. But as I have said earlier, that we will give preference to the set of locants, lowest set of locants. So the first example is correct, while the second naming is incorrect. Now let's discuss the fourth rule, that is presence of more than one same substituents. Now in these examples, we will see that the substituent is same, but it occurs in the chain multiple times. Suppose it is occurring 2 times, we say, or we add the prefix di, If it is for 3 times, then it is tri. If it is for 4 times, then it is tetra. 5 times for penta, and for 6 it will be hexa, and so on. Now let's understand this rule by taking this example. So we are selecting our longest continuous chain, that is of 3 carbons, and we are numbering it as 1, 2 and 3. We can clearly see that 2 methyl groups are occurring at the same carbon. So we will write the name as 2,2 dimethyl propane. So please remember that position of the substituents, they are indicated separately, and the numerals representing their positions, they are separated by commas. Now let's discuss next rule, that is naming different substituent. In the previous rule we have studied the naming of a same substituent, but in this we will study different substituent. So they are basically named in the alphabetic order. There is a very important point in this rule, that we must remember that prefixes such as di, tri or tetra, which we have used in the previous rule, we will ignore while comparing the substituents in this particular rule, that is naming different substituents. We will name them according to the alphabetical order, irrespective of the prefixes di, tri or tetra. Now let's understand this rule by taking the following example. Now we are selecting this as the longest carbon chain. So we have a 5 carbon chain, this as a substituent. So we can clearly see that there are 2 different substituents, one is the ethyl and the second is the methyl substituent. So we will name them according to alphabetical order, as E comes before M. So we will write it as 3-ethyl, 2,3 dimethyl, because we have 2 methyl groups, and 5 carbon chain atoms, that is pentane. Now the next rule is basically naming different substituents at equivalent positions. This is basically the 6th rule. So if 2 different substituents, they are present at equivalent positions from the 2 ends of the chain, then the numbering of the chain is done in such a way that group which comes first in the alphabetical order gets the lower number. This rule is again very important rule while naming organic compounds. Let's understand this rule by taking the following example. Now suppose this is our longest carbon chain of 7 atoms. So we have methyl at the third carbon. If we have decided to number it in such a way, and ethyl at the fifth carbon. But suppose another student wants to number this longest carbon chain in a different manner. So let's first draw this molecule again. Now suppose I want to number it as this, which is basically different from the first case. So we have a ethyl group at the third carbon and methyl group at the fifth carbon. So if we carefully read out the rule again, so alphabetically E comes before M. So in the first case the name could be 5-ethyl 3-methyl. Heptane, because it is 7 carbon chain, but in the second case it is 3-ethyl 5-methyl heptane. Now if we look at the rule again, we have to number according to the alphabetical order. So this is our correct formula or name, while this is the incorrect one. Now moving on to the next rule, and this rule is specifically very important for the NTES exams like IIT-JEE mains or NEET. Now the rule is naming the complex substituents or the substituted substituents. Now let's elaborate this rule. Now this particular rule says that if the substituent on the parent chain is a complex substituent, that is basically it is a branched substituent. Now please remember, we are not talking about the simple substituents, we are talking about the complex or the branched substituents. Then it is basically named as a substituted alkyl group. By numbering the carbon atom of this group attached to the parent chain as 1. Now, this is again a very important point. Whenever we number these type of complexes, then do remember that the carbon parent chain that should get the first number, the atom that is attached to the parent chain, that should get the first number. So, the name of such substituent is basically given in brackets so that we don't get confused with the numbering of the parent chain. So, we generally write such substituents, such complex substituents in brackets. Now, let us understand this rule by taking this example. Suppose we have this molecule and suppose I decide to take this as the longest carbon chain, and I decided to give it the number in this specific way. So, we have a 9 carbon chain, and on the 5th carbon we can clearly see a substituent, but this substituent is basically a branched substituent. So, that is not a simple substituent, but it is a complex substituent. So, as our rule suggests, we have to name this substituent, complex substituent. Now, if we carefully observe this, so this is a 3-member carbon chain having 2 methyl groups at first and second carbon. So, this becomes 1,2-dimethyl propyl group, and we have 9 carbon main chain, so it is nonene. Now, this is a very important point, that when the same substituent or same complex substituent occurs more than once. Now, this rule is very important because most of the time children get confused where should we use bis, tris or di-tri. So, please remember that while naming the same complex substituent which occurs multiple times, we don't use di for 2, but we use bis for 2, tris for 3, tetrakis for 4, pentakis for 5 and so on. This is a very important point if you are giving IIT-JEE mains and NEET exams. So, let us understand this by taking this example. Suppose we are having this organic molecule, now we have this complex substituent occurring 2 times. Now there is a same complex substituent, but it is occurring 2 times. So if we name this complex substituent separately, so this is basically 1,1 dimethyl propyl group. We have given first carbon that is attached to the parent chain. It is getting the first number. So this is again 1,1 dimethyl propyl. So this complex substituent is occurring 2 times. So we won't write it as di-1,1 dimethyl propyl. No, because this rule says that whenever the same complex substituent occurs more than once, it is indicated as bis for 2 and tris for 3 and so on. So the name will be 5,5 because it is occurring 2 times bis 1,1 dimethyl propyl 2-methyl decane, as the longest carbon chain is basically of 10 carbons. So methyl is present at the second carbon, so we have named it as 2-methyl decane. Now let's take this example again. Suppose we are having this organic molecule and we want to name it according to the IUPAC system of nomenclature. Now the longest carbon chain is basically of 10 carbons. Suppose this is how I am numbering it. On the 4th carbon we have a complex substituent, that is basically isopropyl group, and on the 5th carbon we have secondary butyl group. Now this point is again very important because sometimes student gets often confused that whether we should use iso or whether we should consider iso or secondary or di or tri while giving preference to the alphabetical rule, or whether we should ignore these terms. So please remember that di, tri, secondary, tertiary, they are basically ignored in the alphabetizing while iso, neo, cyclo, these are not ignored. So this is again a very important point, that we will ignore the terms di, tri, secondary, tertiary. However, the prefixes like secondary or tertiary, they are not ignored, but in the case when we are comparing these with each other. Suppose we are having a molecule in which we have a secondary butyl and a tertiary butyl. So in that case we won't ignore secondary or tertiary. So in that case secondary butyl precedes tertiary butyl. So this rule is again very important. So the above molecule will be named as 5 secondary butyl 4 isopropyl decane. Now we haven't ignored isopropyl. Now let's do this question and check ourselves whether we have done these rules perfectly or not, whether we are able to solve this problem with the help of the previous rules. Now the question says the incorrect IUPAC name of the compound is 3,3-diethyl butane. Now write its structural formula and correct name of the compound. So according to the given question, we have 3,3-diethyl butane. I am plotting this molecule, but the question says that is an incorrect IUPAC name. Now what will be the correct IUPAC name? I have selected this as the main carbon chain, that is the longest continuous carbon chain, and this chain is having 5 carbon atoms. So the substituents are ethyl and methyl. Now the correct name of the molecule will be, out of ethyl and methyl, alphabetically E comes before M, so the name will be 3-ethyl, 3-methyl, and for 5 carbons the name will be pentane.